All right, guys, super quick video. I know that we've played with the rational root theorem long enough, so I'm going to try to make this really quick for you guys. Okay, so the rational root theorem helps us identify possible rational roots for the purpose of graphing a polynomial of a higher degree. So what we are doing is we're taking the constant term, right, and the leading coefficient, and we are going to find the factors of those two things combined to see if we can find a rational root using the synthetic division. So P stands for the constant terms factors, and that's 1 times 35 and 5 times 7. Those are the only ones that I can get to 35. The constant term is 1, which I can label as Q here. And again, this is all plus or minus. So I'm going to divide these things to find the possible rational roots. 1 divided by 1 is 1. I'm going to go in order numerically. 5 divided by 1 is 5, and then 7 over 1, and then 35 over 1. Okay, and remember that these are all plus or minus. So technically speaking, I have 8 possible rational roots. Now, what we're going to do is we're going to use synthetic division. And I'm going off camera because I'm trying to stop Titan from eating the chair. And now eating the poster. Okay, I get it, okay. And we're going to find this out. So I'm just going to do 1, and because of time purposes, and the dog might end up eating me, I'll just give you the answer for that. So let's just use positive 1. It's the easiest one to use. So positive 1 in synthetic division. Now I've got a 1, I've got a 1, I've got a negative 13, and I've got a 35. Synthetic division, I'm adding down. So 1 goes here. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. That's negative 11. Negative, I don't know if you can hear me. Negative, hey, come on. Okay. And then 35 and negative 11 is 24. This should be 0 in the circle. Because it's not, I know positive 1 is not my rational root. Now, the correct answer is, I think it's negative 5. And you'd have to go through the rest of them to find that. I would certainly stay away from larger numbers because that's just typically not going to be an answer. So I think negative 5 was the rational root. So let's try this again. 1, 1, negative 13, and 35. Remember, I'm adding down. The 1 comes down. 1 times negative 5 is negative 5. That's negative 4. 27, negative 35, 0. Done. So I know that negative 5, or the factor x plus 5, is my factor and root. And now I've got us a nice kind of neat quadratic, x squared minus 4x plus 7. And I can use the quadratic formula, or I can use anything else I want to go ahead and solve for that, and I can find my other roots. Now clearly, if I only found one of these rational roots, the idea is that there's not going to be another one, because rational roots come in 3 or 1 for this particular polynomial because of the fundamental theorem of algebra. So because I only found 1, the likelihood of it having 2 more is extremely low. So it's probably going to have 2 irrational roots. Bam! Thanks, Titan. Cut that really short, buddy. Let's just take a look. He was chewing that poster. Say goodbye, everybody. You bum. Bark, bark, bark.